Okay. So you all know how to open your lab manual, right? This. Okay. So you have to go to your main section. Under labs, we have lab manual, and it is chapter 6. Okay. Normal probability distribution. Now, you have seen this, you have heard about this in your lecture class as well, called as normal distribution. So what is this normal distribution actually? It is a type of probability distribution which is symmetric about the mean. So what do I mean by that? So let us see some example of normal distribution. Okay, so here if you can see, this is mean, right? You all know this. This is mu is called as mean, whereas sigma is called as standard deviation. You know this, right? So this is the midpoint. That means the, how can I see this? The pattern on either side of the plot will be same, which is called as symmetric. Okay, so these type of plots, we call that as normal distribution plot. And the distribution here is called as normal distribution. Okay, so this distribution is a type of probability distribution. Fine, so probability distribution is the main thing. So under that, we have normal distribution, we have called as chi-square distribution, binomial distribution, all those things. So you have studied about normal distribution till now. Then what is probability distribution? So probability distributions will be something like this. It looks something like this. Okay, so this is an example of a die has 6 sides, right? So that is thrown 2 times. So these are the outcomes which we get when we throw a die 6 times. So 36 means the total number of outcomes. So when you throw a dice 1 time, it is 6, right? When you throw a die to a second time, you multiply the outcome. 1 over 6 into 1 over 6, 1 over 36. Okay, so 36 is the total outcomes, and that is why we have the numbers 36 there. Now, what can you infer from this picture? We can easily say that the number 7 in a die will appear most number of times. Okay, so this is how the probability distribution will be helpful. So this picture here is an example of probability distribution. Now, let's not dig into that too much. So you must also know about this, which is called as quantile plots, or in short, we call it as QQ, where Q stands for quantile. Now, why do we use this, and how does this look? So this is one example of QQ plot. Now, this line, the straight line here, is very important. So the points which is circled around the straight line, those are called as data points. So if your data points are straight, are moving in a straight line, so this is called as reference line. The red one which we have here is called as reference line. So we need our data points to be in reference or parallel to that line. So if your data points are parallel to that line, then we call that data set as normally distributed. Okay. Now, why do we actually need the normal distribution? Any idea? Any guess? We always say that we want our variable to be normally distributed. Why is that? It's because you don't have to find median or mode if you know the mean. Because in normal distribution, the mean, median, mode are all same. Okay, and that is why we always want our variables to be normally distributed. Okay. Okay. So we will see more about this in GMP. Let me close this. Okay. So that is some theory about normal probability distribution. Okay. So let us go straight to the assignment question. Now, I want you all to do one thing. So they say that the data which is given in the assignment will vary from semester to semester, and we have to check this in the Blackboard. So I want you to do one thing. You have to open your lab manual on the one side. And I want you to go to Blackboard and then click on Upload Lab Assignment. Upload Lab Assignment. We have assignment 6 here. So I want you to compare these questions which is mentioned here and the questions in your lab manual. So if that is correct, then we can proceed. Sure. So just check whether it is same or not. If it is same, then we can proceed. I guess it is same, right? Now, one more thing is assignment 5 is due on October 15th, that is in 3 days. So you will definitely have a 10% penalty because the actual due date was on October 8th. So if you submit, if you have time till October 15th to submit your assignment 5 with 10% penalty. And your assignment 6 will be due on 19th. Okay. So having known about this, we will start our assignment 6. Is this maximize? Okay. So let us do our first problem here. So they are asking us to plot a histogram. You all know how to do that. Along with that, we have to do QQ plot. And what is that called as? Quantile. Okay. Here Q stands for quantile. Quantile plot, or also known as normal probability plot. Okay. Now we have to do that for each numeric continuous except ID variable. We are not supposed to do this plot for ID variable, except that we are supposed to do for all the numeric continuous variable in our subset of small town data set. Now based on this, we need to check whether it is normally distributed or not. Okay, so let us start. Open your GMP. Now remember, in this we will be using subset of small town, and also we will be creating a new data table. Okay, we will come to that later. So let us do this first. Use this file, open. I guess I don't have. Let me download this. You don't have to do this if you have your small town subset of small town file. Yes, 30. Okay, so this is your subset file. Now, now you have your subset of small town. So what is the first thing to do? You have to show the histogram and QQ plot. So before that, I want you to tell one more thing. Okay. So here in your lab section 212, there I have uploaded some templates under the course content. Okay, under the course content, I have uploaded some templates. That is nothing but your format for the Word file. So I will just use that template as of now. Now I'll just download this. Okay, so this is the template which I use normally. Okay. Okay, so let's start with the report first. Write your name, your section, and date. You can write this as assignment 6, problem 1. I'll just copy this, the first sentence. 1 under 1, we have A. So 1A is this. Do this and then we can proceed. Madison, let us not use the template for this assignment. So let us create the Word file. Done? Okay. So now go back to your subset of small town. Now we will start plotting the histogram. So how do you plot histogram? Go to analyze, distribution. Analyze, distribution. Now I will show you a short trick here. You might have known this. So you can select the variables at a time. Okay. Analyze, distribution. You're not supposed to do this for age, I mean for the ID variable. Other than that, you can click on the variables where you are supposed to plot the histogram. Oh, why am I getting like this? You can use the control command on your keyboard. Okay. You have to select all the blue color variable, the blue one which you see next to the variable name. Done? So once you are done with this, just drag this to the Y column, everything to the Y column. Once you are done selecting, drag it to the Y column and then click on OK. You want me to do this again? No, we are not supposed to do that for the ID. Except ID, we are supposed to do for all the blue color variable. Okay. So anyone in the WebEx, do you have any trouble doing this? Okay. So once you are done with this, click on the red triangle here. Now, before that, let me tell you what this means. So this is the histogram, the green one which you have with the bar, that is called as histogram, right? Now, what is the plot next to the histogram called as? Exactly, the parallel box plot. So what does the parallel box plot do? It will show all the 5 quantiles necessary for the calculations or for the information we need. Okay, so it consists of all the 5 quantiles, also known as 5 number summary. Okay, so that is parallel box plot. Now what is this red line here? So this red line tells us this is nothing but the reference line which I told you about the QQ plot, right? In QQ plot, I told you there is a reference line, right? So that reference line is nothing but your red line which you can see here. So this tells us that whether it is skewed to the left or to the right, or whether it is normally distributed or not. So if you're not able to plot a QQ plot for in some situations, then you can take a look at this uh, parallel box plot, and if you see this red line here, it is not exactly in middle or in alignment with this box, right? It is skewed a little bit. So we can say it is not normally distributed. However, we don't have to do this for our lab assignment. We can plot called as QQ plot. So for that, you have to click on the red triangle in the variable name. Okay. In the variable name, you have a red arrow. You have to click on that and click on quantile box plot. Quantile box plot. You already have this. Do this again. So, so you have to click on the okay. So you have to click on the normal quantile plot. Okay, go to red arrow here, click on normal quantile plot. Normal quantile plot, you get this picture. So this is called as QQ plot. Okay, this is called as QQ plot. And the green line which you see here is your y-axis. Okay, so to plot this, to have this plot, okay, now that you have this, so you have something like this, right? So you have to go to the red arrow under the variable name, red arrow, and then choose normal quantile plot. Normal quantile plot, and you will get this picture. Okay, so this is called as QQ plot, and in the picture you can see the green line, a dotted line, that is your y-axis. Yes, only normal quantile plot. Okay. Now this red line which you have here is called as reference line, as I told you. Now the black dots which you can see are your data points. Okay, data points for the variable age. Now this is not exactly normally distributed. You can clearly see that. It might be close to the reference line here, but if you can see, there is a deviation, there is a curve. So what I need is, I need my data points. Now if this is your reference line, I need my data points to be above the reference line or else below. It cannot be like this, cross. It cannot be a cross. Okay, it cannot deviate. If it is deviating, then it is not normally distributed. Okay. Now, if you still have confusions, like if you have trouble finding out whether it is normally distributed or not, then go ahead and plot the bell-shaped curve, which is normal distribution. So for that, click on the arrow mark there, click on the arrow mark under the age variable, go to continuous fit, and fit normal, continuous fit and fit normal. Now, once you do that, you will get a bell-shaped curve, the green color, which you can see on the screen. So this will easily tell you whether it is normally distributed or not. So I need a bell-shaped curve. Now it is definitely a bell-shaped curve, but if you can see the bar graph, histogram graph, it is outside the line, right? So some are inside, some are outside, and it is not easily, it is not, you can easily say that it is not normally distributed, right? Because some are outside, some are inside. Okay, so you can check whether it is normally distributed in three ways. So in first way, you can check the parallel box plot, and if the red line which you can see here, if it is not in reference or in middle of the line, which in line with the box, then you can say it is not normally distributed. Second, you have to plot the QQ plot. Here, if the data points are deviating, if it is crossed, then it is not normally distributed. Third, you can plot this bell-shaped curve and check whether these data points, the plot here, the histogram, whether it is in shape with that bell curve or not. Okay, so there are three ways to check this. Now, in all these three, we can easily say that this age is not normally distributed. Okay, this is how you have to do. Now, I want you to do this for all the variables, but before that, let me tell you how to paste the graph. Now, I don't want you to paste the whole thing, but you can click on the selection tool. Now I need only these two. Okay, only these two, the QQ plot and the histogram. So how do you choose that? How did I do this? Go to your selection tool and you will have some space under the next to the histogram. Okay, you have some space before the histogram. Click on that space. You can see my cursor here. You have to click on the space next to the histogram. Both has to get selected. Okay. Done. Okay. So once you are done with this, Control C, go back to your Word file. Now, before you paste a graph, you have to mention the variable name. Okay, you have to mention the variable name and Control V. Control V. You can paste it in a picture format also. Okay, that's it. This is what I want you all to do now. Repeat the same step. Okay, so now that you have plotted for all the numeric variables, now first part is done. Next part is we need to check whether it is normally distributed or not. So I don't want you to write the conclusion part in the first problem. So we will be writing it in the third part. So before that, we have to complete the second part, right? Now, for the second part, they are saying us that we need to apply some transformation so that we can convert the variable which is not normally distributed to the normal distribution. Okay. Now, I want you to select one variable which is not normally distributed. one variable which is not normally distributed, and then we will be applying transformation to that variable. So transformation can be applied in two methods. First method is you can use a logarithmic function, or you can use a square root transformation. Okay, now let's see how to do that. I will teach you two methods. You can use any one of them, any one. Okay, let me close this. Okay, now go back to the subset of small town. Now, the age is not normally distributed, so I will choose this, or let me check which variable is not normally distributed. Don't do this step. I'm just doing this for my reference. Okay, so whichever variable is not normally distributed, select that variable. Now, right click on the variable. Now, I want you to choose one variable which is not normally distributed, and I want you to click on that variable. Okay, do not click on the age variable. If your age variable is not normally distributed, then you can follow my steps, or else you have to choose any one variable which is not normally distributed. Remember, my diagram, my plots and your plots will be definitely different because of the sample size. Okay, choose one variable which is not normally distributed, right click on the variable, right click on the variable. Okay, now click on formula. Okay, sorry, uh, click on the variable and click on new formula column. New formula column. Done. Now click on transformation. You don't have to click, you just have to drag your cursor there. Now we have square. So these are the list of methods of transformation. Okay, you can choose any one, but according to the lab manual, we can use any those two, log or square root. So let me use log. Okay, you just have to click on the log. So I will show you how to do this again. Click on the variable, right click on the variable, new formula column, transform. Now here, from here, you can choose log or square. Okay, log or square root, log or square root, any one. I'm choosing log. So once you do this, you can see a new column next to that variable. Okay, you will definitely get a new column next to that variable. Done? Done? So once you are done with this, once you have applied the transformation, now we will be plotting histogram again for this variable. So how do you plot the histogram? Go to Analyze, Distribution, choose the variable which has been applied a transformation, the new column which you created, that column. Okay, so in my case it is log of age. Click that and click on OK, and then you can click on normal quantile plot, and then continuous fit, fit normal, and then you can paste the same picture likewise like you did for the other variables. Okay, now do this and let me know if you have any questions. Yes, yes, that's a B, 1B, 1B, applying transformation. Okay, you can mention the variable name and then you can proceed. mention the variable name here. Then you have to paste the histogram here. Do you want me to repeat any steps? Excuse me. Okay. So once you are done doing this, doing the 1B, now for 1C, they are asking us to summarize the findings in a table format. Okay. For that, I want you to go back to your report file and create a table like this. Okay, mention it as 1C table and go to insert table, and I need 3 columns. 3 is enough. 3, and you can select the whole thing, 8 rows. Okay, so once you do this, in the heading, type as variable, normal or not, normally distributed or not, or else let me, normally distribution. transformation. That's it. Done. I want you to create a table like this. Now mention all the variables you have created a graph. Only for the variables which you have plotted a histogram like this. What else do we have? BMI, and that's it. Okay. So now check whether your variables are normally distributed or not. Then you can answer your as yes or no, whether it is normally distributed or not, yes or no. Okay, fill this table. I don't want it to be exactly in reference to the line, but at least similar. Okay? It has to be slightly similar, at least. It has to be slightly similar to your normally distribution plot. Yeah, something like that. So once you are done filling the second column, now for the transformation, you have to go to the variable wherever you have applied the transformation. So in my case, I have applied transformation to the age variable. So I will say, yes, I have applied the transformation, and mention which transformation you have applied. I have applied logarithmic transformation. Okay, if you have applied square root, mention it as square root. Now, if you have not applied transformation to the other variables, you can simply fill as no, if you have not. That's it. So likewise, fill the table and then let me know once you are done. Once you are done completing your part 1, 1A, B, C, 1A, B, C, after that, we will move on to second part. So here they are asking us to choose a variable which is normally distributed before the transformation is applied. Okay, so you have to choose a variable which is normally distributed in the first part, and then you have to compute the mean and standard deviation. So x bar here is mean, s is denoted as standard deviation. Okay, so once we do that, we are supposed to calculate x1 and x2. Okay, we need to compute these numbers using the formula, and then we will be finding the probability of those numbers using simulation. Okay, so here in part 2 we will be doing two methods and we will be comparing with the two methods. So in method 1 we will be doing simulation. In method 2 we use a calculator, TI-8384 or Casio. So in using the calculator we will calculate the actual probability, and we will also do the simulation and we will compare the result. Okay, so that's what we do in part 2. So let's do along with me so that you will not get lost. Okay, now you are supposed to choose a variable that you found to be normally distributed. Choose any variable which is normally distributed. So let me choose as system. This is in my case, but in your case, it might be different. Okay. Once you do this, once you choose a variable, go back to here, compute mean and standard deviation. I will paste this here. Now you can write it as mean equal to and standard deviation equal to. Okay. So now how do you compute the mean? Now go to analyze distribution. You have to choose the variable which you have selected. Okay. So I just randomly chose selected systolic blood pressure. This is only in my case. Okay. Now choose that variable and plot the histogram. Red arrow, display option, horizontal layout. Okay. Once you do this, here you can see the mean and standard deviation is already given. So you can see in this box here. In the summary statistics, there you have mean and standard deviation. Okay. So you have to make a note of that somewhere in your report. So in my case, it is mean is 117. So I'll write that here, 117 with a decimal. Do not round it off, 117.01, at least two places, two decimal places. So standard deviation is 11.88. Done? Okay. So once you are done computing the mean and standard deviation, and next, go back to your GMP, go to File, File, New, Data Table, New File, Data Table. Okay. Now rename this column as X, rename this as X, click on OK, done. Now I will be applying a formula for this. So go to right click, formula, right click, formula. Okay. So here click on random because we are doing simulation for random integers. So click on random and random normal. Okay, random normal. So here we need to enter mean and standard deviation, but we have one box, right? We need two box because we have two entries. So if you need another box, you can click here, insert. So you have a tool on the top of the box, which is called as insert arrow mark, up arrow. Okay, click on that. You will have two box now. Done. So here, this is not the part of the assignment, but I just wanted to ask you this question. Here it says mean as 0 and sigma as 1. So we know that sigma is standard deviation, right? So for which variable of for which distribution is the mean equal to 0 and sigma as 1? In which distribution have you seen mean equal to 0 and sigma as 1? Yes, it is a probability, but which type of probability distribution is that? Standard normal distribution. That's what we are studying in chapter 6. Okay, so for standard normal distribution, we have mean equal to 0, standard deviation equal to 1, always. Okay, now, so coming back to the assignment, now click on mean and you have to enter the mean value whichever you have got. This, I don't need this. Okay, so mean for in my case is 117.01. So go back to your formula sheet here and enter it as 117.01. Enter your mean value. Okay, enter the mean whichever you have got. Enter. Now enter the standard deviation value. So in my case it is 11.88. Done. So enter mean and standard deviation. It has to be mean first and then standard deviation. Okay. And then apply. Click on OK. Apply and then click on OK. Now go back to your data table here. So once you have applied the formula, you are going to add the rows. So how do you add the rows? Just double click on the column here. Add rows. Double click on the column here. Done. So here we will be doing 10,000 simulation. 10,000, enter it as 10,000. Okay, and then click on OK. 10,000, click on OK. Do along with me. Okay, so once you do this, you have got some values, which is X value. Okay, now after doing this, let me sort these values because it is not in an order. So I need this in ascending order. So I will go to tables, table, sort, table, sort. Now click on X and click on by. X by. Okay, so now I need ascending. So if you can just move your cursor to the up arrow there, it says ascending. So you have to click on that, ascending. Okay, so once you do that, click on OK. Click on OK. Now you will have another data table. Now you will do everything from this data table. Okay, so now this is in an ascending order. That is what I need. It starts from 71 and it goes on. So now this is in ascending order. So once you do this, now go back to your Word file. Go back to your Word file. So what we do here is compute x1 and x2. x1 and x2. How do you compute x1? x1 equal to, so for this you have a formula in your lab manual. x1 equal to x bar plus 1.25 into s. Mean minus 1.25 into s. So here s is standard deviation. Okay, So use your calculators and then you can calculate the x1 value. You just have to enter the mean and standard deviation. In the same way, we have to calculate x2. So x2 formula is in the lab manual in your assignment question, which says x2 equal to x bar plus 1.35 minus s. Mean plus 1.35 into s. So take out your calculators and calculate this value. You must be getting some value. So once you are done computing x1 and x2, so now you can see the formula which I have written here. We need to compute the probability of those two. Okay, we need to compute the probability of those two values. Okay, so how do we do that? Now you can follow the formula which I have written here. In x2 place, you have to write your x2 value. In x1 place, you have to write your x1 value. Okay, you just have to subtract those two values. Now remember, I told you probability of x2 and probability of x1. Okay, now you cannot write these two values. You cannot write the values which you have got there, x1, x2, not that. To get the probability value, you have to go back to your data set here, okay, which is in order. Now search for the value of x1. Now in my case, x1 is 102. Now I will go to here, I will search for 102. You have to search for the value x1. Okay, the starting value. So in my case, I told you it is 102. So my 102 starts here. So I will choose this. Now the value which I have chosen is 1043, the row number. So I need that row number. That will act as your probability. Okay. So in my case, x1 is 102. So all you have to do is go back to your data table and search for that value in the X column, and you have to record the value whichever is next to that. I mean the row number of that value. So in my case, it is 1043. So what I do is I will go here and I will write somewhere here. Okay, simulation number is how much? 1043, which is nothing but your row number. Okay, likewise, you have to do for x2. Is 133. It's not there? Then your calculations might be wrong. Is your calculations correct? Which number are you not getting? Oh, that's okay. You can choose the close one. Yeah. So you don't have to choose your exact number, at least a nearby value. Lost? Okay. So did you calculate that? Did you apply the formula? Okay, go to formula, random normal on the top. It's there. Now you have to click on the insert button there. On the top, you have a up arrow, right? Yes, yes. So now in place of mu, in place of that, you have to enter your mean value. What is the mean you got there? No, that's okay. Yes, standard deviation. Enter. Apply. Okay. Now add the rows. Double click on that. No, next to that. Yes. 10,000. Okay. That's it. Now go to tables. Oh, wait. Tables. Sort. And click on X. By. And click on OK. Oh, wait. Ascending. Let's do ascending. So up arrow there. Yes. Okay. Now maximize this. So you will be doing everything from this. So go back to your Word file. Maximize that. Okay, you need to compute this first. Okay, So mean is 157.10 minus 1.25 into S. So the formula which you have written next to that is wrong. Yeah, so it is mean is 157.10, then minus 1.25 multiplied with 25.91. Okay, so do this in your calculator and write the answer there. Good. So now what you are supposed to do is just subtract those two numbers and divide by 10,000. Yes. So once you get this simulation number, what you have to do is just subtract those two numbers. Now let me do this here. In my case, it is 1043. Okay, so subtract those two numbers, 9109 minus 1043. Okay, and divide whatever you get the answer as, divide that answer by 10,000. Okay, so once you're done with that, you can say this is method 1 simulation. I have written that on the top, method 1 simulation, and after that at the end you can write simulation probability and your final answer. Okay, now for method 2, using calculator. So I know, I guess you must have been known by now how to do this. Okay, so what you have to do is follow this step. Take out your calculator, second, and then you have click on VARs. Okay, so there you have something called as normal CDF. Upper, mean, and standard deviation. This is what you have to enter there. Now, in our case, okay, so we are finding the probability for what? So in my case, it is 102. So before I do this, let me write my x1 value, which is 102. 102.16, and x2 will be equal to how much? 133.04. Okay. So once you do this, now what numbers do you have to fill in? That depends on your problem. So lower value will be x1, upper value will be x2, and mean, whichever you have got, mean, and standard deviation. Oh, we need to do this in the report. Okay. Is using your calculator, find the final answer. So the true probability will be equal to. If you don't get this, let me know. The simulation probability and the true probability are close enough. Okay, that's it. That is your main conclusion. Okay, so once you are doing this, once you are done doing this, you can save this file and submit it in the Blackboard. So that will be the end of your lab 6.